Hi everyone. So now we are going to understand theoretical analysis with the help of one example. So let's say we have a code which follows the following kind of a pattern. Okay. We have two nested for loops. The first loop goes from I equal to 0 till I less than equal to n minus 1 and I is incremented. Okay. And inside it we have another loop which starts from I plus 1 goes till n minus 1 and j also gets incremented linearly one by one. So we want to compute the time as a function of n. So let us try to figure it out. Okay, so we need to count how many times these two loops are going to run together. So inside these two loops we are doing a constant work, so this work can be written as k, but these loops are going to run some number of times. So let us see what happens when the value of I is 0. How many times the inner loop is going to run? It is going to run from 1 to n minus 1, that is, it is going to run n times. Okay, and when the value of I is going to increment to 1, the inner loop is going to run n minus 1 times. When I is 2, it is going to run n minus 2 times. And when I is equal to n minus 1, this loop is going to run just one time, or it is going to just run 0 times. Okay, so effectively if you look at this pattern, how many times these two loops are going to run? So it is nothing but it's the total work that we are doing. It is constant into the number of times these two loops are going to run. So it is n plus n minus 1 plus n minus 2 plus up to 1. So you can see this is nothing but k times summation of n, and summation of n is nothing but uh, n into n minus 1, n into n plus 1 by 2. So this function looks something like this. It becomes kn square by 2 plus kn by 2. Now we see that this is how the time is dependent upon this particular function, and in terms of big O notation we can say this is going to be order of. So both the loops together are going to run approximately n square times, hence the complexity of this code is order n square. That's it. Let's see one more example in the next lecture.